Hi everyone, we are from National Defense University of Malaysia and we will be present about development of biosorbent using banana peels, assessment of hydrophobicity and oleophilicity. So I will begin with the introduction which includes the problem statement, research objective and research questions. Then I will continue with the literature review, methodology, result analysis, and followed by the summary of findings, and finally the conclusion, and at the end, the reference. So, to begin with, the problem statement highlight that the oil spill remain one of the major environmental challenges affecting marine ecosystems. They harm aquatic life, disrupt marine biodiversity, and are costly to clean up. Traditional cleanup methods such as mechanical recovery, chemical dispersion, and in situ burning are still widely used but have major limitations because they are expensive, toxic, and not environmentally friendly. Therefore, this study aims to explore natural, low cost, and eco friendly solutions using banana peels as biosorbents for oil spill cleanup. The objective of this study are to study the types of absorbent used in oil spill in marine ecosystem, to analyze the hydrophobicity and oleophilicity of treated banana peels, to evaluate the characteristic between treated and untreated banana peel biosorbents. So based on this objective, the research questions are: what type of natural absorbent have been used for oil spill cleanup? How do drying and grinding affect the hydrophobic and oleophilic behavior of banana peels? How, what are the differences in oil absorption, capacity, and reusability between treated and untreated samples? Previous studies have tested various natural biosorbents such as rice husk, coconut husks, corn cobs, and orange peels for oil absorption. These materials are biodegradable, renewable, and cost effective compared to synthetic absorbents, which are often non biodegradable and costly. Researchers have also shown the pre methods like drying and grinding can significantly improve biosorbents' ability to absorb oil by increasing its surface area and porosity. Based on this finding, banana peels were selected as for the study because they are abundant agricultural waste and have natural oil attracting properties, making them suitable for a sustainable cleanup approach. This research explores the potential of banana peels as a natural biosorbent for oil absorption, providing a sustainable and eco-friendly alternative for oil spill cleanup. So the study followed a structured flow, beginning with a literature review on existing sorbent technologies and effective pre-treatment methods used in previous studies. For experimental process, banana peels were collected, cleaned, and cut into smaller pieces. The samples were then dried in an oven at 80 degrees Celsius for 24 hours to remove moisture. After drying, some samples were ground into finer particles to increase surface area and improve oil absorption potential. The performance testing involved measuring the oil absorption capacity by soaking each sample in oil and calculating the weight difference before and after the absorption. The samples were reused across 4 cycles to evaluate their reusability and efficiency retention. Finally, the results were analyzed and compared with previous studies to identify the key performance trends and determine the effectiveness of banana peels as low-cost biosorbent. This methodology demonstrates on how agriculture waste can be reused innovatively, supporting the concept of circular economy in environmental protection. So, we move on to the result and analysis. For the data for drying batch of the banana peels, the first cycle showed an oil absorption capacity of 0.64 grams of oil per gram of biosorbent G per G. However, the four cycles, the OAC decreased to 0.24 G per G with only 37.50 percentage efficiency retained. This decline occurred due to pore blockage, fiber compaction, and structural degradation during reuse. This shows that while dried banana peels can absorb oil, their efficiency drops significantly with repeated use. In the other hand, the data for grinding batch, the initial OAC was 1.12 G per G, which is notably higher than the dried samples. After 4 cycles, it decreased to 0.49 G per G, retaining 43.34 percentage efficiency. The improvement is due to grinding, which increases surface area and exposes more pores, leading to better oil absorption. Although efficiency decreases with reuse, the ground samples consistently perform better than the dried sample. This slide compares the oil absorption capacity between dried and ground banana peel biosorbents. So the result shows that the ground banana peels achieve a higher OAC value of 1.12 G per G, while the dried peels only reached 0.64 G per G during the first cycle. The increased performance in ground peel is due to the larger surface area and more exposed pores after grinding. This clearly indicates the grinding treatment enhanced oil absorption efficiency by improving the physical structure of the biosolvent. So this slide shows the reusability performance of both biosolvent types across the 4 cycle. For the dried peels, efficiency dropped from 100% to 37.50% after 4 cycles, while the ground peel maintained a higher performance, retaining 43.34% efficiency. The reduction in efficiency for both samples is caused by pore blockage, oil residue buildup, and fiber degradation. Overall, the ground samples prove to be more durable, but both types are better suited for single-use application due to significant performance decline after multiple uses. From this study, several important findings were made. Banana peels are eco-friendly and low-cost biosorbent. The grinding method achieved higher OAC 1.12 G per G than drying banana peel, which is 0.64 G per G. Both types showed efficiency decline after 4 reuse cycle. Ground peels retained 43.34% while dried peel retained 37.50% efficiency. Pore blockage and structural degradation cause the performance reduction. And finally, the banana peels are most suitable for single-use application. This finding highlights the potential of agriculture waste as a sustainable solution for marine oil spill cleanup. In conclusion, banana peels have proven to be to be an effective, sustainable, and low-cost biosorbent for oil spill cleanup. The grinding treatment significantly improved oil absorption capacity compared to drying. Both treatments showed reduced performance after multiple uses, mainly due to pore blockage, and structural degradation. Therefore, banana peels are more suitable for single-use application, and future research should aim to improve their durability and reusability through better treatments and methods. And that concludes my presentation. Thank you for your attention.